Welcome to this video. So today we are going to solve this integral from the Berkley Math Tournament 2022. So the integral is a rather curious one and it might look complicated at first, but we are going to break it down into steps. So we have the integral 0 to 1 e to the power x plus e to the power x plus e to the power e to the power x. We can call this integral I. Now in order to solve this integral, this is a very complicated one as it looks, but the solution is pretty simple. So first of all, I will, without explanation, take a function which looks like this, e to the power x. Just for the sake of it, what does this function do? So if we were to differentiate it, you would get f dash x equals to e to the power x into e to the power x. As simple as that. But this quite doesn't work because even if you were to multiply it using the rules of exponents, you would get x plus e to the power x. But this function kind of serves the purpose of what we are doing here. So what if we increase it one-fold? So what if we make a new function which looks something raised to the power this? So this function could be e to the power f of x. So we started with a guess of what this could be, and this actually gave us some fruitful results. So now f2x, where this is basically e to the power fx, would simply give you f2 prime of x should be equal to e to the power f of x into f dash of x. That is correct. Now, what is e to the power fx? E to the power fx should be simply e to the power, this whole thing, right? So, e to the power x multiplied by e to the power x plus e to the power x. Now, if you apply the exponents, that if you are multiplying with the same basis, the exponents basically sum up. You get e to the power x plus e to the power x plus e to the power e to the power x, which is nothing but our integrand in general, right? So the function f2x works, which is e to the power fx. So basically there would be three e's. The motivation behind taking this function was I simply noticed that e to the power x is there, then there is a e to the power x, and then there is a x. So basically, if a bunch of powers of e's are concatenated upon each other, then while differentiating, since e differentiation of e to the power x is e to the power x itself, these things add up because all the bases are same. So the exponents will just line up and add. So that is what I did. So now then our integral I would look something like this, 0 to 1, and it is simply the differentiation of f2x dx. According to the fundamental theorem of calculus, this simply equals f2 of 0 minus f2 of 1. Sorry, the reverse obviously. f2 of 1 minus f2 of 0. Okay. Now what is f2 of 1? So f2 of 1 should be e to the power f1. So basically e to the power f1 minus e to the power f of 0. And what is f of 1? So we can check that f of 1 is simply e to the power e. And f of 0 should be e to the power 0. So we can write that. So e to the power e to the power e to the power 1 minus e to the power e to the power e to the power 0. Simplify this. So this becomes simply e to the power e to the power e minus this term becomes 1. So this simply becomes e to the power e. So this is our final answer. So this was not a complicated problem. The only thing is you have to understand the guess of the function, that why we are choosing a function and what is the motivation behind choosing that function. So it's a very nice problem from the Berkley Math Tournament, and it has been this kind of format has been used a lot. So thank you for watching, and also if you're new to the channel, do subscribe. I always bring this exciting integrals and new theorems and a lot of help for exams like JEE Main, JEE Advanced, ISI, CMI, and also Olympiads. And let me know in the comment section if there is anything else. Thank you.